Let's look at this example. The cumulative of a continuous random variable is given as follows. Find the values of the constant a and b. We need to understand the special characteristic of the cumulative distribution function where the value before and after is the same value. For examples, for the values of -2, we have 0. So when we substitute x equal -2 into 1/12 times 2 plus x, it also gives us 0. So, to solve this questions, we compare the value of upper limit 0 in the second interval and the lower limit 0 in the third interval by substituting them into the cumulative function respectively. By comparing, we got the constant a is equal 1/6. We now want to find the value of the constant b, so, we use the same technique as we did in finding the value of the constant a. We know the values of 6 is 1, so if we substitute x equals 6 into b plus x/12, it also will gives us 1. By comparing, we got the value of the constant b is half. For questions in b, we want to find the probability density function from the cumulative distribution function. We use real number line as our guidance. Sketch the number line and writing down the values -2, 0, 4, and 6. We can see there is 5 intervals. The first one is x less than -2. The second interval is x is greater than or equal -2 and less than 0. The third interval is x is greater than or equal 0 and less than 4. The fourth interval is x is greater than or equal 4 and less than 6. And the last interval is x is greater than or equal 6. We write down the cumulative function for each interval. Now, start with the first interval. The probability density function is the derivative of cumulative distribution function. Here, our cumulative function is 0. Differentiate 0 will give us 0. For the second interval, the probability density function is the derivative of the cumulative distribution function. Here, our cumulative function is 1/12 times 2 plus x. We differentiate this function and it will give us 1/12. Moving on to the third interval, again the probability density function is the derivative of the cumulative function. Here our cumulative function is 1/6 times 1 plus x. The differentiation of this function is 1/6. For the fourth interval, the probability density function is the derivative of the cumulative function. So, differentiate 1/2 plus x/12 and we got 1/12. For the last interval, our cumulative function is 1. So probability density function is the derivative of cumulative function. Thus, differentiate 1 will give us 0. For the final answer, we write down the probability density function as follows. To calculate the probability of x from 3 to 5, we use cumulative function to make it more easier. If we sketch the graph of the cumulative function, the probability of x from 3 to 5 is in this area. We know that capital F of 5 is the probability of x less than or equal 5. Capital F of 3 is the probability of x less than or equal 3. Here, the capital F of 5 is this area and capital F of 3 is this area. So, the probability of x from 3 to 5 is capital F of 5 minus capital F of 3. Capital F of 5 is in this range. Substitute the value of x equals 5 into the cumulative function of 1/2 plus x/12. while capital F of 3 is in this range. Substitute the value of x equals 3 into the cumulative function of 1 over 6 plus x over 6. Simplify this equation. Then, we got 1 over 4.